Hello, my name is Manteja. I am from CSAMLA section. My topic name is Loss of Photoelectric Emissions. In this picture, we can see about photoelectric emissions, and a metal is present on a metal plate. The light rays are reflect passing through it. So, after passing the light rays, there is an electron emission from the metal plate. Now, we will see what is photoelectric emission. The process by which free electrons are emitted from the metal surface by the application of light is called photoelectric emission. It is also defined as the process by which free electrons are released from the metal when it absorbs light energy, and the process by which free electrons are emitted from the metal surface by the application of light is called photoelectric emission. It is also defined as a process by which free electrons are released from the metal when it absorbs light energy. The photoelectric effect is the emission of electrons when electromagnetic radiation, such as light, hits a material. Electron emits Electrons emitted in this manner are called photoelectrons. The phenomenon is studied in condensed matter physics and solid state and quantum chemistry. Is drawn is to draw inference about the properties of atoms, molecules, and solids. This effect has found use to electronic devices specialized for light detection and precisely timed electron emission. The photoelectric effect is the emission of electrons when electromagnetic radiation, such as light, hits a material. Electrons emitted in this manner are called photoelectrons. This phenomenon is studied in condensed matter applied physics and solid-state quantum chemistry to draw inference about the properties of atoms, molecules, and solids. The effect has found use in electronic devices specialized for light detection and precisely timed electron emission. In this picture, we can see about photoelectric effect. The photoelectric effect when the here we can see the white and red atoms which are connected in a metal which are present in a metal. So here the blue are light rays which has been observed by metal, and after observing the light surface the metal surface will emit electrons outside, like we can see the red particles coming out from metal. So this phenomenon is called photoelectric effect. This is about photoelectric effect. Now we will see what is photoelectric effect and its loss. The photoelectric effect refers to the emission or ejection of electrons from the surface of a metal in response to incident light. This takes place because of the energy of incident photons of light have energy more than the work potential of the metal surface, ejecting of electrons with positive kinetic energy. The photoelectric effect refers to the emission or ejection of electrons from the surface of a material in response to incident light. This takes place because of the energy of incident photons of light have energy more than the work potential of the metal surface, ejecting electrons with positive kinetic energy. And in this picture we can see about photoelectric effect. Here Y is a photon attacking to the electron. After the photon attacking to the electron which is absorbed by a metal surface in an atom, then the photoelectron is ejected from metal. Here the photoelectric effect takes place. In the atom we can see neutrons and protons and electrons. The photon is attacking the electron. The photon, the light rays which are absorbed by metal plates. After absorbing the metal, it, the metal contains more energy, so it emits electron outside the metal surface, which is the ejected electron is called photoelectron. And in this picture we can see the photoelectric emission. Here I have collected it from Electrical for You website. And here in the right side picture we can see the glass envelope and emitter, anode, cathode and electron path which is connected to a battery. Here the circuit takes place and continues to go on, and when the surface of light such as sunlight falls on the emitter, then emitter emits an electron to anode. Then anode will carry the electron to the battery and to the positive side of the battery. So, and the right side picture we can see the photons are falling on metal surface, and through that there is emitted of free electrons takes place. Here the yellow color is the free electrons which are present in metal surface. So this is about electron emission. The photoelectric effect is the emission of electrons when electromagnetic radiation such as light hits the material. Electrons emitted in this manner is called photoelectrons. By these photoelectrons there are many uses such as they are used in electricity and ovens and many other electronic devices. The photoelectric effect is the emission of electrons when electromagnetic radiation such as light hits a material. Electrons emitted in this manner is called photoelectrons. Here we can see the emission mechanism. Firstly, we will see what is emission mechanism. The photons of a light beam have a characteristic energy called photon energy, which is proportional to the frequency of light. In the photoemission process, when an electron within some material absorbs the energy of the photon and acquires more energy than its binding energy, it is likely to be ejected. If the photon energy is too low, the electron is unable to escape the material. Since a increase in the intensity of low frequency light will only increase the number of low energy photons. Here in this picture we can see the we have cathode and emitter, and photons are falling on the emitter. Then emitter emits the free electrons to the cathode. And here is a graph of saturation current, and which is photoelectric current versus collector voltage. The photons of a light beam have a characteristic energy called photon energy, which is proportional to the frequency of light. When a electron within some particles absorbs the energy, then it acquires more than its binding energy. The electrons from the highest occupied states will have the highest kinetic energy. In metals, those electrons will be emitted from the Fermi level. In atoms, there are three levels. One is ground state, and another one is Fermi level, and last one is excited state. Here, Fermi level is in between ground state and excited state. While free electrons can absorb any energy when irradiated, as long as this is followed by an immediate re-emission, like in the Compton effect. In quantum systems, all of these energies from one photon is absorbed. If the process is allowed by quantum mechanics or none of it part of the acquired energy will is used to liberate the electrons from its atomic binding. Here in this picture we can see the stopping voltage versus the frequency graph. Here let us take the example of zinc, and here we can see we observe colors between 4 to 8 Hz, and after that we can see a irradiation like we'll see in the Compton effect. There is a gradual growth in zinc ions, and these electrons from the higher state occupied the will have highest kinetic energy. In metals, these electrons will be emitted from the Fermi level. Now we will see the formula of Now we will see the formula of photoelectric emission by conservation of energy. This reasoning led Einstein to a photoelectric equation, which is Ek equal to Hf minus chi, where Ek is the maximum kinetic energy of an ejected electron. By the conversion of energy, the reasoning led Einstein to a photoelectric emission, and here we can see the formula of photoelectric emission, which is Ek equal to Hf minus psi. Now we will see the relationship between the frequency of an incident photon and the kinetic energy of a emitted photoelectron. Firstly, we know the equation E photon equal to psi plus E electron, and the second one is h nu equal to h nu naught plus half mv square v square, where E photon signifies the incident photon's energy, which is equal to hv, and psi signifies the metal surface's threshold energy, which is equal to hv naught, and E electron is the photoelectron's kinetic energy, which is half me square. Me is the mass of electron, which is equal to 9.1 into 10 power minus 31 kg. I hope you all understand about the photoelectric emission. Thank you.